I'm Anil Kumar, sharing with you strategies to do integration. We have taken up trigonometric functions. Now, integrating trigonometric functions is kind of tricky. You need to remember a lot of formulas and the identities. Here is the one which relates tan and secant. We need to find integral of tan to the power of 6x secant 4x dx. Now let me remind you how they are related. So whenever you have trigonometric functions, try to look into their relations. So one, we know that 1 plus tan square x is equals to secant square x. This is one we know. We also know that what is the derivative of tan x. So if I substitute u equals to tan x, in that case du can be written as secant square x dx, right? So does that give you some idea? So it really means that I could split this secant to the power of 4x into secant square x and another secant square x, replace the secant square x by 1 plus tan square x, and replace tan with u. That should give us the solution, right? So that's the plan. So what you can do now is pause the video, try to solve this, and then look into my solution. So as we have discussed, the strategy here is simple. We'll write tan as such, split secant into secant square x times secant square x. Basically, we are keeping one secant square x aside with dx, since we want to use this part, right? Okay. Now, secant square x can be written as 1 plus tan square x. We'll write this as tan to the power of 6x, and that is 1 plus tan square x times secant square x dx. Perfect. Now it's time to substitute. U is tan x, so we'll write u to the power of 6, 1 plus u square, and that is du. Open the bracket. It's like a polynomial. So it's u to the power of 6 plus u to the power of 8 du, whose integral is u to the power of 7 over 7 plus u to the power of 9 over 9 plus c. Replace u with tan x. So you get your answer, tan to the power of 7x over 7 plus tan to the power of 9x over, I should have written 9 here, over 9 plus c, right? So that is how you are going to solve such questions, correct? Now we'll have another video to solve similar question with slight variations, you can say. And that is to say, instead of having combination with even powers, we could have this function with odd powers. For example, we could have this as tan 5x secant 7x dx, right? Now in that case, what strategy would you use? Well, this formula remains as such. Now, you know, if I write u equals to secant x, in that case, what is du equals to? Du is secant x tan x, right? So that is how we'll be related. So what we can do in this case is we can keep secant x tan x separate. So the integral could now be written as integral of tan to the power of 4x secant to the power of 4x, and then we have secant x tan x dx. Do you see that? And now we have these even powers which could be related with 1 plus tan square x equals to secant square x, and the substitution is secant, so we'll replace this with 1 plus tan square x. You get an idea, right? So we could write this as 1 plus, let me write here again, tan square x will be equals to secant square x minus 1, right? So we'll replace tan x with secant square x minus 1. Since secant is u for us, so we'll write u square minus 1 whole square, right? And we're replacing this with u to the power of 4, and we replace all this with du, right? I just saved a step here, and I hope you can fill this up. we have another video to provide you with complete solution. Once you have this kind of a polynomial, then you can easily find the answer, right? So I hope that works for you. So look into strategies while solving such functions. That will always help, and build on your library. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.